Hello, I'm Shivani. Welcome to this video on Shor's algorithm. In 1994, Peter Shor, the American mathematician, has demonstrated the enormously important problem, that is the problem of finding the prime factors of an integer and the so-called discrete logarithm problem. It could be solved efficiently on a quantum computer, and this has attracted widespread interest because it was and still are widely believed to have no efficient solution on a classical computer. Shor's algorithms gives us the way of factoring a large number into the product of its prime factors. This might not seem that important, but our internet security depends on this problem and it's being hard to solve. Being able to factor products of large primes number threatens our current methods of securing transaction between computers. Might some time until we have quantum computers that is powerful enough to factor the large computers and that are currently in use, but the threat is real and it is already forcing us to think about how to redesign the ways that computers. And these days lots of research is going in the field of post quantum cryptography. So before we give a brief description, we look into the brief description. Let's look into the problem that Shor wanted to tackle. RSA encryption. The RSA encryption method is named after its inventors, Ron Rivest, Eddie Shamir, and Leonard Altman. They published a paper on it and then patented it in 1978. And these days, it is widely on internet for encrypting data sent from one computer to another, and it is used for internet banking and for electronic purchases using credit cards. So, what is exactly happening in this? Suppose when you want to communicate with a bank, we need to encrypt our data so that if somebody intercept, it can't be read. The actual encryption of the data is going to be done by using a key that both can use to encrypt or decrypt the data. That is called a symmetric key and must be kept secret by both parties. The key that is generated on our computer and sent back to the bank, but of course we just need to send the key without encrypting it. We need to encrypt the key that we are going to use to encrypt our communication with the bank. And this is where RSA encryption enters into the picture, and it is the way of securely sending the key to the bank. So, protocol of Shor's algorithm. Suppose n is a positive integer, which is the number and for which the prime factors we need to find, and n is equals to p multiply q, where p and q are the prime factors of that integer n. So first thing we need to do is the order finding. Suppose a and n be the positive integers with no common factors, such that a less than n, that is the co-prime numbers. The order of a is the smallest positive integer, let's say r, such that a to the power r is equal to 1 mod n. Now let's define a new variable, say x, and if r is even, then the condition x is equals to ar by 2 mod n. If suppose x plus 1 is not equal to 0 mod n, then we will go for factors p, q, that it at least contain the following GCD, that is the greatest common divisor. So GCD x plus 1 comma n, GCD x minus 1 comma n. If any of these systems not satisfy and fail, then we'll simply go for another a and start over again. So this is what Shor's algorithm is. Now let's look into its Qiskit part, Qiskit implementation. So I have already created the Jupyter Lab a Python notebook. Let's start doing it. First we need to import, okay, sorry. First we need to import everything from Qiskit. For that we use asterisk. Then Qiskit.algorithms, import Shor. Okay. And so all we get to do is just create a backend by saying quantum. After importing these libraries, air.get backend Quasm simulator. Okay. And the reason why I called the quantum instance rather than the backend or something like that, because this Shor's algorithm that we imported in the very first part ask for these parameters like quantum instance and so that's why I named it like this. Of course, we can name this variable anything we want, and since we have imported these shores in the very beginning, we can just go ahead and use it. So we are going to create a instance out of this shores algorithm, and it actually asks for the backend that will be working on. So the backend parameter is the quantum instance, and then calling Shore, I can simply copy and paste it to save the time. Okay, and it is very easy to get the result back, and we have to just say result is show dot factors factor. Okay, so we have to just say, okay, just have to write the number that we want to factor. I am taking okay, 15, right? And also we need to specify that random number, that is a I am going with, I am taking it 7. We need whatever we want to choose, and we can choose different random number as well. Here I'm using 7. Okay, then we need to just write to get the result, print factors result dot factors, and it will automatically give the result. So here are the factors 3 and 5, that is 3 into 5 is 15. So it is as simple as that using the Qiskit. So that is all about Shor's algorithm. Hope it is clear. Thank you.